Okay, everyone, have you found a place? You have a cup of coffee, some cookies?
Can you see the slides? Okay.
I would like to wish you all very welcome to today's sustainability talk. And I first want to say something about sustainability talks. That's a series of seminars, transdisciplinary seminars here at Uppsala University Campus Gotland. And our aim, we are a small group working with these seminars, and today it's an anniversary, actually. It's the 1 year since we started this series. And it's an ambition to focus on sustainability issues in the perspective of the United Nations Sustainability Agenda, the sustainability goals for 2030. So we want to connect education and research, and thereby we invite guest lecturers, we have student presentations, we have seminars and so on. And today we have Kevin Anderson, the second holder of Sennström Guest Professorship in Climate Change Leadership. And last year, the first sustainability talk was with the first professor, Doreen Stabinski. So maybe some of you were here then also. But Kevin comes from England, Manchester, Manchester University. You're a professor in energy and climate.
Yes.
There. Yeah. And also deeply involved in Tyndall Center for Research on Climate Change.
Yes.
And you're going to talk today about what will happen with the Paris Agreement. How can we reach the Paris Agreement?
Yes.
Very welcome. We are very happy to have you here and eager to hear what you are saying.
Okay, thank you very much.
Kevin.
It's a pleasure to be here. Can you all hear me with this Madonna microphone? I feel I should be singing, which you wouldn't want to hear, but anyway. The other thing is, can you all see the slides okay from where you are? It's going to be quite a bleak angle for some of you. Okay, well, I'll be talking through them, so unfortunately they're not projected onto this screen, so you can't see them on there. Well, I've called this talk here, are you sure you can see that? Yeah, it's maybe my eyes as I'm getting old. Accelerating towards Paris, how informed hope and action can trump despair. And you can obviously see the capital T there for trump despair, and maybe you want to ask me about that later. And if you've got any difficult questions, this is put together with my colleague Jesse, who's over there. So he's good at asking. He's previously lived on Gotland, so he knows lots of things about Gotland. So any difficult Gotland questions, Jesse's your man. I also have a Twitter account for those people that use that sort of modern fangled social media stuff, but I do use it quite a lot. But I only use it for work, so I don't use it to say where I've been cycling or rock climbing or what I've had for tea. It's just a sort of boring works one. But I link to things that I do and other things that I read of other people's that I think are worth reading. I'm going to start off with this slide here, which is quite a new one. I just put it on recently, actually, just about where are we on climate change, and it'd be interesting to know you're a younger audience than sometimes I'm talking to, so you may put yourself in a different place on this. But we belong really to tribes quite often when we think about issues, world views, if you like, gestalts. There's different ways of thinking about this. And I just wonder where you would place yourself in this. And sort of theoretically, it's often called the sort of political culture hypothesis. There are denialists, which generally they don't tend to live anywhere outside of Texas, but and for these people, usually the world is 6,000 years old, and God put fossils there to chip humankind up, so that that's their sort of view of the world, and you can't really make any scientifically based arguments with them. There are the other denialists who just say the science is fundamentally flawed, and there are fewer and fewer of that particular group now who just say the science is just simply wrong. And I would argue there's virtually no one with any sort of scientific foundation is now making that. There are the skeptics, and they basically agree with the broad premise of the climate science, or at least they do now, but they say the climate sensitivity is low. In other words, that we will not get a lot of warming in the atmosphere for the additional carbon dioxide that we put into the atmosphere, so they're not particularly concerned about it. And then probably the biggest group of the skeptics, and I'm saying that because probably I come much more from the UK, but I think even across continental Europe, is that they say that climate change is real, but the impacts will be small. And anyway, our growing economies will mean that we can buy our way out of the problems. And you often hear that in the UK. There's quite a well-known group in the UK called the Global Warming Policy Foundation, headed by a previous Chancellor of the Exchequer, Nigel Lawson, who also presided over very high interest rates and big inflation as well. But anyway, he often says that the economy will be 8 times bigger by 2100. So we'll have plenty of money to buy our way out of climate change. So there's some cogency to those arguments. There's some elements that make some sort of sense in there, but I still think we have to really sort of maybe go much further than that. There are the incrementalists. Now, this is where I reckon that almost those people who think climate change is a serious issue, this is where 99% of us actually live. And we say the science is correct, adequately correct. Climate change is a really important issue, but the carbon price and some utopian view of technology that we can deliver on the Paris goals of 1.5 degrees C and 2 degrees centigrade. And the great thing about this is that we can all do this within the current socio-economic paradigm. So we haven't got to change the way that we've framed modern society. And that's, I would argue, where most scientists live, or at least that's where they won't dare stray out of that one, put it that way. If they have to put a microphone in front of them, they always say they live in that one. And then there are the radicals, or as you can see, my bias on this, the realists, that the science is correct, and that climate change is a really important issue, but that the Paris framing of 1.5 and 2 degrees C is incompatible with global aggregate economic growth. And I'm not saying that some of the poor people can't see continued economic growth for a long time to come, but as an aggregate of the globe, that is no longer compatible. You can't reconcile that and that. And that this begs fundamental questions about our current socio and economic paradigm. It demands profound system change to the world in which we live. And I'm probably going to try to argue today that I think we have now chosen to go into the final one because we've chosen to fail on this one here. So I don't know where you'd put yourselves in that. As I say, most scientists, most academics, most policymakers, most of the public, I think we probably put ourselves really, certainly from the way we behave, in the incrementalist one, that we hope things can be solved with some utopian technology. I'm going to start off with the main part of the talk with a quote that I've been starting to use quite a lot recently from Richard Feynman. Have any of you heard of Richard Feynman? He's a very famous, probably one of the most famous 20th century physicists. Unfortunately, died a little bit prematurely. But if you ever want to look at any really interesting lessons on physics, he makes it, it's really fascinating. He's also a good bongo player and a safe cracker. He was an all-round very interesting character. But he was also very good at inquiring about things in ways that other people hadn't thought to do. And this is taken from when he was the chair of the President's Shuttle Commission in the US after the Challenger accident, which not many of you here will remember, I don't think, because it was quite a long time ago, in 86. But that was the space shuttle that blew up, and he was inquiring into that. And there's a really good TV film about that inquiry. But this is taken from that inquiry itself. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. And I'm going to try to demonstrate that. I would argue that we have collectively, as a scientific community, as an NGO community, the charities and so forth that work on climate change, as the business leaders that work on climate change, the policymakers, across the board, we have tried to fool nature. And my argument is that probably nature will win. It's had 13 billion years of natural laws and the laws of physics. And we've had about 30 years of ephemeral economics. And we somehow think the economics now is more important than physics. My guess is in the end that we will always lose out if we think that the laws of nature will always win. He obviously wasn't talking about climate change, but I think you can apply Feynman's view to climate change. My provocation that I made in quite a few presentations I gave at some of the main climate centres around continental Europe anyway, prior to Paris, was that in developing 2 degrees C emission scenarios, are you all familiar with the 2 degrees C framing of climate change? Are any of you not familiar with it? Speak up. No? You're all familiar with it? Okay, fine. I'll come back to it a little bit later anyway. But in developing 2 degrees C emission scenarios, we've applied questionable assumptions and fine-tuned our analysis to fit with political and economic sensibilities. In other words, we're not prepared to say the things unless they fit with the current way the government wants it to fit. And I would argue, I know scientist after scientist after scientist that's like that. You put a microphone in front of them and they will just say things that fit with what the government have really said about climate change. You put a pint of beer in front of them or a glass of wine and no microphone, and they'll talk quite differently about these things. There's a huge pressure on scientists to conform to a certain economic norm. You see the research councils that fund the research in the UK, all their strategy documents are saying that our research, whatever that research is, will contribute towards the competitiveness of the UK and ongoing economic growth of the UK. Now, that may do or may not, may or may not be the case, but surely that should not be what determines what we fund. So I think we have been really trying to fool nature for a long time. Now, this is a backdrop to Paris. This actually happens to be our carbon dioxide emissions, but as I regularly say, you can plot anything on this. It could be television ownership, how far we drive, how many cars we have, what's the world population, how often we fly, and I often point out it could also be human arrogance. That any other species that did this, we would know was going to die off fairly quickly, and yet we think we can somehow do this and carry on forever. Remember, economists do tell us that growth can go on forever. Are there any? I shouldn't ask if there's any economists here. That's a bit unfair. What's disturbing, I think, and really people of my age, so I often say this, if people with no hair, dyed hair, or grey hair, people of my generation should start off with a very heartfelt, sincere apology to quite a few of you here, people of the slightly younger generation. I hate to think that I'm an older generation now, but it'll happen to you as well. So the first IPCC report from the Intergovernmental Panel on Climate Change, the group that collects most of the data on climate change, and that came out in 1990. We knew everything we needed to know in 1990. Now, and who wasn't born here in 1990? So, and quite a few of you were fairly young in 1990, I think. So we can't really blame you, not yet. But we have chosen to fail your generation. We have chosen to hand on to you a disastrous future that we have really reasonably well understood, at least since 1990, if not a little bit before that. And that was an explicit choice to do that, because we were not prepared to make changes to how we lived our lives to protect your future. So remember to blame us. Remember to look at us and make us work much harder than we are now. Push us really hard when we say things like, we couldn't possibly do that. We've already stuffed your future to a high degree. So make us really appreciate that we owe you large changes in our lifestyle to give you a more promising future. And I think this is really quite sad that a quarter of a century has been our legacy of failure. It's been worse than that in some respects. The emissions this year will be 60% higher than they were in 1990. It's not that we haven't failed to get the emissions down. We've actually managed to succeed in putting the emissions up by 60% higher this year than in 1990. So it's not starting off very well, this story. In terms of temperature rise, the other thing that's really important that came out of the latest set of IPCC reports, which is sort of 2013, 2014, was that in terms of temperature, what really matters across the century is the carbon budget. How much carbon dioxide we put into the atmosphere across the century, and I'll talk to that in a bit more detail in a second. And this is fundamental in understanding what we need to be doing from a policy perspective. And yet at the moment, and I don't say many wonderful things about the UK, but one thing about the UK is the only country in the world that has a carbon budget framework for its climate change policies. But the carbon budget framework is very, very unfair and based on a very large carbon budget, not for 2 degrees centigrade. But it's the only country in the world that has a scientifically based target at the moment. It's the carbon budgets that matter. It's not something about a 2050 target. It doesn't matter what happens in 2050 or 2030. These have nothing to do with climate change and never have had. They're misleading. They allow us to think, well, we can solve the problem with the technology in 2030 and 2040. But actually, the carbon budgets tell you that's too late. The more we emit today, the less we can emit tomorrow. And this has major political repercussions, which is why we don't really like the science. We prefer the astrology than the science. If we think of this graphically, I've put some pictures of Gotland in that I had the pleasure of hunting out at between 3 and 4 o'clock this morning, actually. Anyway, so it looks very nice, Gotland, but I haven't seen it. I've only just seen it in the sunshine recently, so which I'm not sure whether does that happen quite often, sunshine. Jess and I were checking the stats yesterday. It is one of the sunniest parts of Sweden. That's not saying a huge amount, really. Yeah, but I come from Manchester, so it's probably not too dissimilar. So think about this graphically. What we see from 1990, this is carbon dioxide emissions here, and the years at the bottom. From 1990 up to today, we see an ongoing rise in emissions of that 60% or so. What matters for 2 degrees centigrade or any temperature across the century is actually the area under the curve. This is the carbon budget. This is what matters. So the more you use up now, the less you can use up later. What happens in 2050 doesn't really matter, or 2030. It's that total area. So if we choose to, this is just diagrammatic here, but if you just choose to fail, as we historically have been doing, so emissions are higher, we use up more with the carbon budget, that means that we, and when I say we, and when people of my generation say we, what we mean is you will have to make more stringent cuts later on in your lifestyles. If that's possible, of course, it may be that we've left it too late. You can't make those cuts anymore, so you no longer can achieve those temperatures. And that means you have to have much, much higher rates of mitigation, which is a fancy academic word for reducing emissions. So the carbon budget framework does have quite a significant implication in how we should think about policies. And with Sweden now thinking about a climate change law, it needs to think about carbon budgets as framing that law. So this is Gotland. I make sure I get the right pictures off the. Yeah, I made one mistake which we discovered just before coming down here. I thought, is Malmö a province of Gotland? No, okay, well. So returning to the Paris Agreement, when you're at the Paris negotiations, no, okay, well, about 40,000 people were, and probably most of them flew there. So this is the Paris document, not the world's most exciting read, but it is an important document. And I'm going to focus on this particular paragraph here. But for those people with whose eyes are my age, I've blown it up a bit, to hold the increase in global average temperature to well below 2 degrees centigrade. Notice that it says well below. It doesn't say a 50-50 chance of, or the UK government's policy is a 63% chance of exceeding. It says well below 2 degrees. And make efforts to limit temperatures increase to 1.5 degrees C. To do this in accordance with the best science, which is probably collectively is the IPCC, though that is always a little bit out of date. And also to do it on the basis of equity. And that has a huge implication for what that might mean for the wealthier parts of the world and in efforts to eradicate poverty. And if you put these together, 2 degrees C, 1.5 degrees C, best science and equity, you can start to say quantitatively what your country needs to do, what you need to do globally, what your country needs to do, what your province needs to do, your municipality needs to do, what your university needs to do, and probably for people like us, probably what our lifestyles need to be doing. You can actually quantify the rate of change we need to be delivering. And you can then test, are your policies in line with that rate of change? So that's again why we don't like this sort of thing, because it allows us to be able to test how badly we're failing. I'll also say now that, I'm going to come back to this a little bit later, but let's be quite clear that the 2 degrees C is no longer seen to be a safe threshold. I would argue it never really was seen as a safe threshold by the poorer parts of the world. Many people will die at 2 degrees C of warming. They'll be poor, they'll typically be non-white, they'll live a long way from here, and they will have had almost no part in bringing about this problem. And again, this is quite disturbing. Not only have we not cared about our own children, people of my generation, but we have certainly not cared about those poor people elsewhere in the world, some who already are being impacted by the sort of first early signs of climate change, exacerbating other tensions they're already suffering in some parts of the world. And that's why places like Bangladesh and the small island states pushed really hard for 1.5 degrees C of warming, because there was a feeling in those communities that they might just be able to deal with 1.5. But when we think what it means, for 2 degrees centigrade, some of the small island states will no longer exist. And they no longer exist because in the UK and in Sweden and other parts of the world, we wanted to keep burning lots of fossil fuels. We would think it was completely unreasonable if it was the other way around. If they kept burning fossil fuels and we had to move out of Sweden or the UK, we would think that was wrong. But we think it's perfectly reasonable for us to impose our will on other parts of the world. And it's not just those areas. You look in Bangladesh, there's about 30 million people live within 1 metre of sea level rise of the coastal strip of Bangladesh will be affected by this. So I have the Paris Agreement is really good that we have it. There are some major problems with it. It's very weak on many regards, far too many regards, but I was going to touch on some of the issues I have with it. Firstly, it's a 32-page document, and it makes no reference to fossil fuels or decarbonisation in 32 pages on climate change. And the main reason for that is that you need to keep the Saudi Arabians on board, and because they're interested in fossil fuels, but also your morally bereft cousins on the left in Norway. They want to be kept there, and they want to, of course, pretend to be green whilst get as much oil and gas out the ground they possibly can, along with Britain, of course, with its North Sea oil. So these countries don't want fossil fuels mentioned in there. But the whole thing is a sort of horse trading poker game. Did any of you hear about the discussion around the word should or shall? Well, there was a huge discussion around this because the word shall in the US means you can take me to court. And the Americans didn't want anything where people possibly could take any entity involved with climate change to court. So they argued for about 2 days that it should be should, because should is not, we should eat slightly less fatty foods. We should do a bit more exercise, but we don't. We're not compelled to do it. You can't be taken to court for not doing not doing those things. And so there's, these arguments go on throughout the 2-week negotiations, and actually well before that. Aviation and shipping emissions, international aviation and shipping emissions were exempt. That's the equivalent of emissions from the UK and Germany added together and growing much faster. Aviation expects to at least double its emissions by 2050, even with lots of improvements in efficiency. And shipping is looking to triple its emissions by double to triple its emissions by 2050 as well. So these sectors are not included and are looking to increase significantly. The promises that we all made, and Sweden made it via the EU, as did the UK at the time, but of course we're soon to leave the EU. Anyway, if you add all of them together, there are 3 to 4 degrees C of warming. Now, a cold day in Gotland, that doesn't sound too bad, but the difference between now and an ice age is about 5 degrees. So we're talking about almost geological sort of levels of change occurring in about 100 years. So this is, as I often sort of say, it's effectively, from any sort of geological or ecosystem point of view, it's like a meteorite hitting the planet. This is how fast this is occurring. It's almost instant. So 3 to 4 degrees C of warming. That's where we're going. If you add our promises together, what's also quite worrying about that is that until 2023, we're not going to review these seriously. There's going to be a review of the potential review in 2018, but the actual review itself is not till 2023. That's 300 billion tons of CO2 from now, of which 20% will be in the atmosphere, changing the climate for at least the next 10,000 years. So we are locking in tremendous levels of change already. And the whole premise, the edifice of the Paris Agreement, indeed of the UK government's policies, and no doubt the Swedish government's policies and thinking about this as well, is premised on negative emission technologies. And many of the people writing the policies are not even aware of this. A lot of the scientists were not aware of this till very recently. The other scientists and economists that have come together, a particular group of them called integrated assessment models, have been using these negative emission technologies to sweeten the pill, to make the mitigation challenge look much more acceptable. And I'm going to come back to those in a bit of detail later. So before Paris, we were heading this direction, 4 to 6 degrees C of warming, according to the International Energy Agency, and quite a lot of the climate scenarios sort of suggested that's the direction we were heading. With Paris, we're heading for 3 or 4, but really, if we're blunt about it, it's not because of our judicious, carefully crafted climate change policies we made that shift. It's because the bankers collapsed the world economy. So that's the reason that the emissions are not going to be going as high as we thought they were. And that's still the case. You see in China significant reductions in the rate of growth, which is one of the reasons Chinese emissions have not been going up so fast. And along with their shift away from coal for air pollution reasons, that's one of the reasons in the last 2 or 3 years we've probably seen it almost stabilizing out of carbon dioxide emissions, not coming down. But we've promised you, some of you here, we've promised poor parts of the world 2 degrees C and actually 1.5, which is even steeper than that. So there's a big difference, obviously, between where we're heading and where we need to be. And I'm going to focus here, because my focus is on energy. And I should say, and I will touch on it briefly at the end, the non-energy part of climate change is hugely important, agriculture, land use, and those things. They're massively important. If you look at someone like Gotland, as I can understand from looking at some of the facts and figures for here, it's a really important part of your economy, of your employment, and also, of course, of your culture and the environment of the island. But I'm not going to be focusing on that side. I'm focusing on the energy side, but we'll try and touch on the agriculture side a little bit later. So what does this mean for energy? Well, it means that in the short to medium term, well, the immediate term, really, immediate to near term, we need very rapid cuts in energy demand. If we reduce our energy consumption today, then we reduce our carbon dioxide emissions today, because most of the energy we use is still carbon dioxide derived or still fossil fuel derived. So we need to have deep cuts there, and I'll talk about that later. Who has to make those cuts? The supply side, as an engineer that used to design and build offshore oil platforms, I actually like bits of engineering equipment. So, the supply side can do a lot. You can build wind turbines and solar panels and nuclear, whether you like it for other reasons or not like it for other reasons. It's certainly very low carbon, about 5 to 15 grams of carbon dioxide per kilowatt hour. So there are lots of technologies out there we can do, but they take a long time to put in place. We cannot build our way out of the climate change problem because we've left it so late. We could have done that if we started in 1990, but because we've chosen to fail, we are now left with this difficult situation about saying we need to cut energy demand. Now, this is all on a global level, and actually what we've promised, of course, to do is to do it on the basis of equity, which basically means, it's written into Paris, it's written into the Camp David Agreement and the Copenhagen Accord as well, that we're going to allow the poor parts of the world will take longer to make the transition away from fossil fuels. They will peak their emissions later than we have, and they will take longer to make that transition. That seems completely reasonable and fair. Well, it's still not very fair, but less unfair than it would otherwise be. So let's go back now to the carbon budgets and to the temperatures that I talked a bit about before. In 3 to 13 years from now, and 13 really is pushing the limit of this, we will have, at current levels of emissions, we will have used up all of the 1.5 degrees C temperature threshold, temperature budget. That will have gone. So from a budget perspective, I used to write, it is now too late, but some NGOs were less keen on that, so I've swapped it to, is it now too late? You know, unless you believe in negative emission technologies, unless they are phenomenally successful and rolled out at scale, we are not going to hold to 1.5 degrees C of warming. We are going to go above that. And I think, again, we have to be honest about that and remind poor parts of the world that they are very unlikely to see that temperature threshold, so they need to adapt to a temperature that's going to be much higher than that, because the chances are they're going to be lumbered with their local repercussions of 4 degrees C of warming, which I'll come back to later. And for 2 degrees centigrade, I've taken out a lot of the maths, so I've just given sort of the headline numbers out of this. For poorer and less industrialized nations, they would need to have zero carbon energy by about 2050. When I say energy, I don't just mean electricity. I mean, you know, planes, ships, refrigerators, cars, industry, everything. Zero carbon by about 2050. And you can work out the carbon budget for that, for the poor parts. That's a huge request of those parts of the world. That does include China as well. And then you say, well, what's left for the wealthy parts of the world? And what's left for us is that we have to be zero carbon by about 2035. So about 18 years from now, we have to be zero or very much approaching it. For Sweden, we're going to have to reduce emissions at about 12% every single year, starting January the 1st this year. And we're already 6 or 7 weeks late, because we're well into this year and we haven't done that so far. And every day we fail means the following day is harder, because it's a cumulative problem. It's about carbon budget. It's not about 2050 or 2030. 12% every single year. Imagine that in your own lives, in your own institution, in this university, you know, across the whole of Sweden, the EU, the US, Australia, Japan. We have to start that now, and that's for 2 degrees centigrade, which will already see many people die. So yeah, it's not a very upbeat message. That's about a 50% reduction for Sweden by about 2025, by 2020 rather, 75% reduction by 2025, and as I say, virtually eliminated by 2035. All of that sounds really difficult, and politically it's hugely challenging. So why is it at Paris we saw high carbon people, you know, cheer with joy at what had been done, and you saw the DiCaprios and the Al Gores of this world jump on their private jets and fly over there and chink champagne glasses with these people? You know, why is it we saw that? And the reason we can hold all of this together is because of something called negative emission technologies, which is, I've seen here, just sort of describing here as a magician pulling a rabbit from a hat. Now, I would say to start off with, I think we should research these. I want to say it's really clear, so I often get criticised for this by people who work on them. I don't know, do any of you work on negative emission technologies? No, but I'll say it anyway, because it's been recorded. I think it's really important that we fund research into negative emission technologies. But I think it's also equally important we assume that they will not work. It's a moral hazard to assume that they will work. Now, if they do work, there's a small chance we might be able to hold to 1.5 degrees centigrade. If we do everything we can for 2 degrees, which I'm going to show is just about possible, and if then the negative emission technologies work, we can perhaps aim for 1.5. If we start to rely on the negative emission technologies for 2 degrees centigrade, then we are locking the future. If they fail, which they very likely will, then at scale, we are then failing future generations, and we will certainly be aiming towards 3 and 4, because we will not have made the changes that we should have made. Now, what are these negative emission technologies? These are technologies that suck the carbon dioxide directly from the atmosphere, which, when you straight away, if you just think about that, there's not that much carbon dioxide in the atmosphere. Even at the moment, it's only about 400 parts per million by volume. So it's not a wonderfully efficient thing to do technically. But one of the ways you can do that is through this thing called BECCS, which is the most commonly used technology in the models. I mean, it doesn't work at scale. I mean, there's almost no, well, there are no power stations that's any reasonable size doing this. And it's biomass energy with carbon capture and storage. And basically what you do is you grow trees and you grow plants, and as they grow, as you're all well aware, they absorb carbon dioxide through photosynthesis. Then you capture those, you chop down those trees, you harvest them, you ship them around the world, which is always missing from the models, which is a shipping industry about the same size as the world's current shipping industry. And you burn them in the world's power stations, which is not a wonderfully efficient thing to do, to burn biomass. You capture the carbon dioxide from the chimney, you liquefy it, or almost liquefy it, then you pump it underground and you store it there for a few thousand years. So that's what we're relying on. This has never worked at scale. There's a carbon capture and storage plant. The only one we have at any reasonable size is the one in Canada. One started a couple of weeks ago in America. But we have one carbon capture and storage plant using coal that we have about 2 or 3 years experience of, and that's the Boundary Dam one in Canada. And that's quite small, about 110 megawatts, which is about a tenth of the size of a decent-sized power station, so it's not a big example. And it's had major technical problems burning coal, using coal. If you use biomass, it's much more chemically variable across a year. And so, therefore, you're going to have far more sort of chemical problems with it, which has been the big issue with the Boundary Dam plant. So this has never worked at scale. There are huge technical and economic unknowns here. There's a big efficiency penalty. Most power stations are only about 35 to 55% efficient. Then you bolt this on the end, that's another 15 to 25% efficiency gone. And there's limited biomass availability. The poor we want to feed the poor and ourselves, so possibly 9 billion people by 2050. We want aviation fuel to be biofuel because it's lower carbon. Well, it could be lower carbon. We want to use it in our ships. We want to use it for our chemical feedstocks. And already about 5 to 7% of our car fuel is actually biofuel of one sort or another. We also probably want to make sure we have some nature reserves on the planet. So we're not going to cover the whole planet in a biomass crop for ourselves. So you start to put all that together on a round planet and just think, does this make any sense? Just to give some sense of the scale of it, it's the equivalent, depending on which models you look at, of planting out the area the size of India every single year, decade after decade, right to the end of the century and beyond the end of the century. And that's because we're not being bothered to move our emissions out of the system today. So this is because we choose to fail. We have to do this in the future. Another way of thinking about this is at the moment we put into the atmosphere about 40 billion tons of carbon dioxide every year, 40 billion tons. Which is, we put in just, that probably doesn't mean much to many people, but the world produces, I don't know the exact numbers for this, but the world produces somewhere in the region of 5 billion tons of steel and about 3 billion tons or so of cement, I think, and probably about 2 or 3 billion tons of municipal solid waste. So the carbon dioxide is at a scale bigger than anything else that we do. At the moment, half of what we put into the atmosphere is absorbed back by the biosphere, by the oceans and by the plants. So about 20 billion tons. And we're planning by the middle of the century, by about 2050, a technology that does not exist, and 2050 is not very far away, to have a technology out there rolled out that will be absorbing up to as much as the oceans are doing today. And by the end of the century, we'll be absorbing about up to as much as the oceans and the plants are today. So it's like bolting on another biosphere. So we're going to invent this thing here. We've got one already. It works quite well. But we're going to bolt on another one. That's what the sort of technology is supposed to be delivering. So it is, we're relying on this. We're doing this. This informs our government policy today about what it is trying to do about climate change. This is what's really concerning. And most of them have no idea of that at all. So Paris, some academics and some politicians, rather than focus on urgent and deep mitigation today, because it has huge political repercussions if we are going to focus on those, and I'm going to come back to that towards the latter half of the talk, we'd rather rely on non-existent negative emission technologies to suck huge quantities of carbon dioxide out of the atmosphere in the future. So it's a very dangerous thing, I would argue, to be doing. And this isn't the first of the scams. Is that a word that translates into Swedish? Scam? Con? We've had a whole series of these. We had offsetting. If any of you are Catholics, it's the equivalent of buying indulgences. You do something wrong and you pay someone else to take away the sin. The governments loved this idea because it meant you hadn't got to do anything. So they developed an official version of it. They gave it a fancy title called the Clean Development Mechanism, where we pay another part of the world, like Ghana or Nigeria or somewhere, to make the reductions for us because we don't want to make them ourselves. Now, it's not to say some of these things might be worthwhile to do in themselves, but they don't absolve us of the responsibility of our CO2. We had the emissions trading scheme, which, but maybe if we put it in with a plan to it working, would have been okay. But we put it in with so many permits in it that we knew it would make not a lot of difference to reducing our emissions. And of course, it hasn't done. The price of carbon at the moment in it is probably about 5 euros a ton. And now we're using biomass energy, carbon capture, storage, and negative emission technologies. My question is, when are we going to try mitigation? We've tried everything for 25 years to avoid reducing our emissions. And it has failed. And yet we're still trying. We're so reluctant to actually reduce our emissions. And I would argue here that if we go back to Richard Feynman, we have completely ignored his advice, and we are trying to fool nature. We think somehow nature will be taken in by offsetting or BECS or nets or some other scam that we come up with. We're not clever enough to defeat nature. So This is you may not have seen this photograph in your brochures, but if you watch an excellent video on Destination Gotland, which I highly recommend, it shows you the wonders of Gotland, and this fine chap there is demonstrating some surfing. If 2 degrees C is too challenging, what about 3 or 4 degrees centigrade? Now, there's not a huge amount of work out there on what the impacts look like at 3 or 4. And at first, of course, we don't live in global average temperatures. I mean, we're scientists. We should never have really used this language. It's not very helpful. If you live in Manchester or Uppsala or Gotland, you say, oh, the world might be 2 degrees C warmer. Oh, dear, what a shame that would be. That sounds quite nice, doesn't it? 2 degrees C, you think that'd be nicer, warmer in the summer. Even 4 degrees C sounds quite attractive. But they're really misleading. And I almost wish we didn't use that language. These are global averages. They're fine for us scientists mucking around with their models and so forth. But for the public, it's meaningless. We need to know what does that mean for our weather, which is really, none of us live in climate, we live in weather. Our infrastructure is designed for climate, but our day-to-day living is in weather. So what does this mean for our weather? And obviously that varies geographically around the planet. So 2 degrees C of warming, we'll see something like 6 degrees C of warming in the poles. So they vary geographically around the planet. But then also what happens during extreme events, and that's often when most of the damage is done. This Pareto's law basically holds for many things in life, that 80% of the damage is caused about 20% of the time. 80% of the damage is caused by 20% of the people. That's a really useful sort of rule of thumb to most things in life. It doesn't always work that often. So just think of the hottest days, the heat waves. Now again, they're hard. That means when you have prolonged periods of warm weather, for those of you who are Swedish, who've not heard of a heat wave before, or Manchester people. But they can be quite severe. And even somewhere like Europe in 2003, 20 to 30,000 people died in Europe. In 2003, 20 to 30,000 people in what's supposed to be an industrialized, catered for society. Now, if you went to that heat wave and you said, well, let's add 8 degrees warming on top of that. If you played that out, what does that mean, 8 degrees C of warming? It would also mean in Sweden that your asphalt would melt on the roads because your asphalt is not designed for those temperatures. These are prolonged heat waves with additional 8 degrees C of warming. Your train lines, which are not the world's best now, they will be buckled. I'm not sure you'd notice a huge difference in Sweden because they're not in good condition, but they would be buckled, so the trains wouldn't be able to run on them. But I think more disturbing when you start to think about sort of detailed parts of our infrastructure, and there's an example I regularly use, is that the power that's brought to our cities comes underground in cables. It comes across the big cables across the countryside, then it comes underground. When it comes underground, those cables are cooled by the moisture in the soil that wicks away the heat from the cables. As you have prolonged heat waves, you lose the moisture in the soils, so the cables now start to overheat. They're overheating at the same time your fridges and your freezers are working really hard to keep your food from perishing because it's a lot warmer than it normally is. You're also trying to keep cool at night, so you're having a cold shower at night because that's the way you people survive, is you drop your body temperature at night. And that's one of the reasons people were dying, because from heat stress, is that if you don't drop your body temperature at night, then you can die from heat stress. So you need to shower at night or have cold baths. But that means you have to have pumps pumping the water to your shower or to your bath. All this is going on. At the same time, your cables are breaking down underground. Your transformers are struggling. So you start to see a collapse of what we think has been a fairly sophisticated, successful, resilient infrastructure. Remember, our infrastructure, human infrastructure, our roads, our buildings, which have been built and put together over the last few hundred years, have been done during a period of remarkably stable climate. Humans have evolved to where we are today during a period of stable climate. And now what we're suddenly shoving into this is a non-stable climate. So our system has not evolved for this. I'm sure if you gave us 1,000 years, we could do it quite well. But not in 50 or 100 years. So you start to see even industrialized parts of the world really suffering, let alone some of the poorer parts of the world that will be this will be exacerbating a whole suite of other problems that they'll be facing. Food crops. At these sorts of temperatures, you're going to see reductions in some of the staple crops of 30 or 40% in terms of the yield. I mean, you could extend the areas that you can grow them on. But you also think about that. If you're starting to see more instability in these parts of the world, is it hard to keep growing more and more crops if your local environment's much more unstable? So you sort of see a whole suite of exacerbating issues here. And in terms of sea level rise, you're talking about 50 centimetres to 150 centimetres by the end of the century. Some people say it could be much higher than that, but most of the estimates are in that sort of range. But the other thing to think about this, I always think this is quite incredible about what we've managed to achieve, that at 2 degrees C of warming, we will very likely have put in so much thermal energy into the system that we will melt Greenland, even at 2 degrees C of warming. So in the next 20 years, we will decide whether or not to melt Greenland. Greenland has about 7 meters of sea level rise, 7 meters. So I don't know where we are here. We probably wouldn't be here. Most of Visby would have gone. A lot of Stockholm, Gothenburg, London, New York, many parts of the world that are, of course, the cities often that we really cherish are those that have some history, have some heritage, and many of those are by the sea. Now, we're not going to see that happen by the end of the century, but we are locking that in. So in the next few hundred years, 2500, which might seem like a long way away, but that we live and operate in a society that has those sorts of lengths in terms of its buildings and its infrastructure. So we are changing fundamentally the shape of our planet. And what I find is even more incredible about this is a bit of a geeky point really, but there is so much ice on Greenland that when you melt that ice, you take the mass of the ice on Greenland and you spread it around the planet because it arrives in the oceans. And gravity relates to the mass of something. You change the gravitational patterns of our planet. Sufficiently so that you may see almost no sea level rise in Greenland. Because you've taken all of this mass off Greenland, you've spread it now around the planet, which changes the gravitational patterns of the planet, which actually what means you'll see more sea level rise in the southern hemisphere than in the northern hemisphere. Now, it will still be having sea level rise once you drop down towards Scotland and that area. But the idea that in about 50 to 100 years of our emissions, we have changed the gravitational patterns of our planet, we will do, is incredible. If it wasn't so sad, it would be amazing that one species could achieve that. So I just think some of the things behind this, some of the numbers, the scale, they are beyond anything we would normally be able to comprehend. I think it's fair to say that at 4 degrees C, there's a widespread view that society will not be in any way, shape or form organised. What normally happens when you stress societies very badly is that men reach for Kalashnikovs and shoot each other. And the women don't come out of it much better in that either. And we see that repeatedly. We saw this in some of the changes in the pasture lands in Darfur. Now, I'm not saying they were caused by climate change. There's some evidence to suggest that they look like they were climate related. We see that to some extent. Some papers now are saying that some of the exacerbating tensions prior to the issues around Syria were again caused by drought issues, not caused by, exacerbated by. Whether that's true or not, I don't know, but there's some papers out to suggest that. We're just not very good at dealing with stress. We always blame others. And I would argue at the moment, look what's happened with the Syrian crisis. A handful of Syrians have arrived in Europe, and we've broken down Schengen. We've broken down the agreements between our countries. We're putting up borders and walls. And it's only a handful of people. Where have most of them gone? There's 1 million of them in Lebanon. Lebanon's 1/6 of Lebanon's population are now Syrians. We have a handful arrive in Europe, and we already collapse infrastructure. So we've spent decades trying to build that system up within the EU, and almost overnight we've collapsed it with a little bit of stress. So I think it's quite disturbing what you start to see when we are stressed as communities. We are not as resilient as we like to think we are, even in the wealthy parts of the world. I mean, you see part of that major reason the UK is leaving the EU is because of issues of migration, because we want to build up big borders. We want one of those Mexican walls that Trump's trying to put up. It's beyond adaptation. Devastating to ecosystems. You would have wiped out the barrier, well, we would have wiped out the barrier reef. We'll have wiped out most of the rainforests, if not all of them, in any way that we'd recognise them today. But also you wipe out, or you significantly change things like the pollinating insects, which are quite important for our crops. So you start to have big impacts on food production as well. And it's highly unlikely to be stable. At 4 degrees C, you're very likely to see additional warming on top of this as you melt the things that people know about, melting of permafrost, releasing more methane, changes to soils which start to metabolize faster and put more carbon in the atmosphere, and the off-gassing of carbon dioxide from the oceans, where a large portion of carbon dioxide is actually currently stored. As the oceans warm up, they can take on board less carbon dioxide and will start venting it. So I think it's fair to say, at all costs, 4 degrees C should be avoided at all costs. I emphasize all there because that stops economists trying to use discount rates to say it's always worth delaying action till tomorrow, which is basically the one message that comes out of economists. Don't do it now, you can do it tomorrow. But actually, this is such a devastating future that you have to do everything you can to avoid this. So I'm going to go back to 2 degrees centigrade. And when I say 2, we're talking about an outside chance of 2. It's not looking very hopeful. My question is it viable? And yes, I think it is. Where is this bit, by the way? This is Gotland, isn't it? No? Oh, I was really excited when I saw this because I'm a keen rock climber. When I found it at 3:30 in the morning, it came under when I put Gotland images, it came up. Oh, but are you sure it's not part of Gotland? Yeah, but you don't think you know your own island. Oh, we think it might be part of Gotland. So is there rock climbing on it? Yeah. It's really what, sorry? Oh, is it? It's not very good, is it? Oh, well, I should have found a better image. Anyway, my hypothesis is yes, we can still hold a 2 degrees centigrade, but it is just. We are talking about being lucky on 2 degrees C and probably nearer heading into the sort of 2.5 to 3. And there are some lots of things we can do with technology. And as an engineer, I'm really pleased we can say that. There are things we can do on the demand side technologies, and these can have a sort of near-term benefit. We can quite rapidly reduce our emissions using technology. On the supply side, there's a lot we can do, but generally it will take quite a long time. Building wind turbines and power stations and electrifying the system and all those other things takes a long time to do. But there's a lot we can do on our behaviours, our practices, our routines, the way we live our lives. And I would argue that equity is a really big driver of that. So I'm going to touch on these. Now, you're not going to tell me, is this a symbol of Gotland? Good. I had to stretch it out a little bit. It was a bit fatter on the image, but I stretched it, so it's a long ram. What's particularly special about these rams? Are they a breed of Gotland, or they are? Okay. They might have a problem from a methane point of view, these, but anyway. So there's a lot you can do with technology. So the things we know about, we're familiar with, this is a geothermal plant that I went to visit when I was in Iceland. There's some wind turbines, nuclear power station. My dad used to work at this one, which has recently been decommissioned, and that's the new one that was built in the UK in the 1990s, so it's not that new. They are low carbon, but there are lots of other issues with them, I accept that. There's hydro schemes. This is the American one, but obviously the Swedes use a lot of these as well. There's solar panels, which are increasingly effective and rapidly reducing in price. There's biomass, which Sweden's got a lot of, but biomass is not always low carbon. It can be quite high carbon if you store it incorrectly, and actually storing huge quantities of it can be really problematic. It has a lot of other issues associated with it as well. You might use fertilizer for growing it and things like that, which can have big NOx effects on climate change. So not always zero, but done well can help. Tidal energy, wave energy, and carbon capture and storage, which is a bit like I was talking about with this BECCS technology. It's basically just burning coal or gas, and you capture the carbon as it goes up the chimney. But this is never low carbon. It's just sort of medium level carbon. It's about, if anyone wants to know the numbers, CCS, the life cycle emissions for carbon capture and storage, are probably about 100 to 200 grams of carbon dioxide per kilowatt hour. Gas-fired power station is about 450 grams, a coal one would be about 900, and nuclear and renewables somewhere in the 5 to 15, depending on the range of assumptions you use. So these are all low carbon supply, but they're virtually all electricity. Not all of them, but they're virtually all electricity. And electricity is only 20% of the energy we consume at a global level for most parts of the world. In Sweden, it's higher. 30% of the energy you consume here is electricity. That means 70% is not electricity. So what do you do about that? And NGOs very often forget that. In fact, a lot of people do. They muddle up energy and electricity, both begin in E and end in Y, but they're quite different. So we need to think about that. You need a massive program of electrification. We need that at a global level, because it's quite hard to know how you how you have zero carbon energy for non-electrical things. Yeah, you can use some biomass, you can use wind on ships. There are some things you can do. You can use solar thermal for some heating and some industry purposes, but there aren't that many. So a massive electrification program. On the demand side, I'm not going to go into any detail here, but it's the area that I work on most with my colleagues. Well, this and the carbon budget work. If you put in very efficient standards on technologies, and you think about most of the technologies, even in this room, there'll probably be a difference of a factor of, I would say, at least 2 in the laptops that are here in terms of the energy they consume. If you start to look at cars, you see that the average American car is about 220 grams of carbon dioxide per kilometre. If you look at the average Swedish car, it's probably about 160 to 170 grams. New cars that have been sold in the EU, about 130 grams. The Italians, the Spanish and the French drive slightly smaller cars that are more efficient. So you start to see big differences in what's available. All the manufacturers now make cars that are between 85 and 100 grams that are petrol and diesel cars. So there are huge differences in the technologies that are there. So the standards could rapidly drive out inefficient technologies. Tighten these year on year. Put your fingers in your ear because you're going to hear the industries squeal. Industries always squeal. And the people that squeal in industries are not the engineers. The people that squeal are the financiers. The engineers like it because you give them respect and say, look, here's a bit of paper. You've got to go out and design one of these. And they think that's really exciting. I'll go and do it. And I'm not interested in Formula One cars at all, but my best friend, he's obsessed by it. He pointed out a few years ago, they went from being 3-litre big engine Formula One cars to 1.5-litre cars because they were trying to reduce the accidents or make them safer on bends because they're going too fast and the acceleration was too quick. It took the engineers 1 year to get the cars to go as fast as the previous year, despite the fact they'd halved the engine size. So it's incredible what you can do when you put a spec to people. So ignore what the financiers tell them and just, within the laws of physics, tighten the standards year on year. You provide a long-term market signal. And in industrial and wealthy nations, I would argue you can reduce the energy demand in about 10 years if we thought climate change was a serious issue by between 40 and 70%. The average Swede has an energy consumption that's twice that of an average Brit. Now, I don't argue your quality of life is on average slightly better than ours, but not twice as good. So you consume far more energy. Now, your CO2 emissions per person are quite a lot lower than ours. We're about 4.4 tonnes per person from a territorial basis and about 7.3 tonnes from a consumption-based. If you take account of the things we buy, our laptops and so forth, and our clothes. But your energy consumption is much higher, but your CO2 emissions are lower because you have a lot of renewable energy, a lot of renewable electricity. So 40 to 70%. We also, I put in here, remember there's the rebound effect, that energy efficiency has never reduced consumption historically. As soon as you save some energy somewhere, it means you save some money, which means you buy a jet ski or you go on another holiday or something. So you just buy more stuff somewhere else. So energy efficiency is really important on climate change, but you have to have policies in place that stop us buying more stuff with the money that we save. And there are lots of techniques you can use and policies you can use to do that. We've never done it historically. We've never put policies in place to stop that rebound effect. It's very well understood. But these technologies, the supply technologies, the demand technologies, they can't deliver on the Paris budgets. So we then end up with the final part I want to talk about is we need rapid and deep reductions in our energy consumption. And I've emphasised here is what we do, how we do it, how often we do it. And this is absolutely critical. If we don't deal with this, then we're not going to respond to climate change. Don't tell me this isn't part of Gotland. Is this Gotland? I was a bit uncertain about this one because it looked a bit too like a tropical island somewhere. Are you sure it's part of Gotland? It did look quite stunning, actually, didn't it? Anyway, so I'm going to look at equity here, and there's a massive CO2 asymmetry when it comes to climate change. By that I mean a massive difference between what some people emit and what other people emit. And broadly it relates to energy, and broadly that relates to income. And it'd be interesting if you took this room here, I reckon Pareto's rule would hold here. You probably find that 80% of the emissions of people in this room come from 20% of the people in the room. And I have done that occasionally. And it is interesting when you do that, because that's usually the split that we have. It's only a rough guide, but you do it in your classroom sometimes. Just have a look. Just do it. Ask people to think about their carbon emissions. Right, 50% of emissions, we know globally, come from about 10% of the population. This is from some work that was done by Chancellor Piketty a couple of years ago now. The top 1% of global emitters have carbon footprints, and this is from the US rather, have carbon footprints that are 2,500 times higher than the bottom 1% globally. 2,500 times higher when we think climate change is a serious issue. If you take Leonardo DiCaprio, who I have quite a lot of time for in terms of he believes, I think he genuinely thinks climate change is an important issue, and he was involved with that film you might have seen recently, Beyond the Flood or Before the Flood, or Before the Flood, which is an interesting film. And actually, I think he's probably better than many of the people he speaks to, even when he speaks to Obama, in that he doesn't believe in all these technical whiz-bang solutions to it. He's very concerned. But the time he really squirms in it is when the Indian lady asks him about his lifestyle and that of his other American friends. And that's the challenge. But to his credit, he kept that. He could have had that cut, but he kept it in. And I worked out for him from the Forbes index that told me about his income, he's equivalent to about 9,000 Zimbabweans. That's what his carbon footprint would be. 9,000. Is it reasonable in this time to do that? Now, the promises that we have collectively made to Paris mean that there will be virtually no reduction in carbon dioxide emissions or greenhouse gas emissions by 2030. None. And yet, if the top 10% of global emitters were to reduce their carbon footprint to the level of the average European citizen, which is not exactly impoverished, the average European, this is an EU citizen, that would be a 33% cut in global emissions. So how come we claim climate change is such a massive challenge that you could get a third cut in global emissions? If you thought it was serious, you could do it in a week. If you thought it was really serious, if you thought it was really serious, you could do it in a week. Yeah, it's a massive reduction. And there's a brutal logic in carbon budget, a really brutal, hard, it's a hard-hitting thing, really. This is the mistake I made. I foolishly thought that was at Visby Airport, which is what I tapped into my search engine, but I realised it's at Malmo, I think, or somewhere not Visby. Those big houses around the back there are not. I don't think they're in Visby. But anyway, it's just a backdrop. Just think of the example of aviation. Every ton of CO2 that we emit when we fly somewhere, it's any other high carbon activity as well, but this is the highest carbon activity that we can do over any 1 hour period. Every ton of CO2 we emit when we fly, and remember that people that fly always have high carbon footprints. Most of the world don't fly. Even in their own countries, actually, most of the flying is done by a relatively small percentage of the population. But for a set carbon budget, when we emit over a reasonable level with our flying, is that we're saying a poorer part of the world cannot emit a ton of CO2, cannot emit a ton of carbon dioxide, if you want to stay with the same carbon budget. And in the short term, what we know for certain is that poorer parts of the world, their access to fossil fuels improves their quality of life in the short term, because their access to fossil fuels gives them access to energy. And that infrastructure is already often available, and it's quite quick to put in place. Great if we can use renewables and things, better still, but nevertheless, that can really help very quickly. So we have this difficult choice now. And we also know very clearly, when we burn more fossil fuels, we don't have a better quality of life on average in our countries. There's some really interesting work, the spirit level work, work done by William Lamb and Angela Druckmann and others, that just show that when you plot emissions amongst quality of life, and a whole series of indices, whether that's female literacy or life expectancy or whatever it might be, that what you find is that there's a small group of countries that have much lower emissions, but actually have roughly the same quality of life indices as the Europeans, and similar to the Americans, who have very, very high carbon footprints. Now, there's also about 12 countries, I think, in that group, and it's none of the usual suspects. It's places like Costa Rica. There's no European countries in there. And there's about 12 countries that are passing through it on the way out to join us and the Americans and the Qatarians. So it doesn't improve our quality of life when we burn more fuel. But when we fly to another conference, there's a moral choice here with the carbon budgets. When we fly to another conference, when we fly to a meeting, or we fly to go on holiday or to spend time with our family, we are saying to poor parts of the world that they can't have access to energy for basic needs, not with the same carbon budget. You can't have both of those. And once you know that, as you step onto the plane or buy the ticket, that's what you're saying to Ghanaians, to Bangladeshis, to some of the poor parts of the world. You're saying, you can't have access to fossil fuels, because otherwise, if we do that, we'll breach our carbon budgets. And it's quite difficult. Once you think about that, it becomes very hard to say, why should I take a larger share than most people would suggest was a fair thing to do? So, well, I'm sure none of you would fly, but anyway. So who's in this top 10%? The interesting, once you know who's in the top 10%, you can start to say, let's aim the policies at that group. Because then you can have a whole new set of levers. Rather than aiming the policies at 7.4 billion people, you just have to aim them at the top 10% of emitters. Well, this group, Climate scientists are in there. They spend all their time flying around the world telling the little people beneath them that they should reduce their carbon footprints as their footprints get higher and higher every single year. And that's true for virtually all academics. Business leaders who like to talk about climate change, policymakers who like to talk about climate change as the House of Commons. The UK, if you're a frequent flyer, if you're on a plane twice a year, then you're definitely in that category. And audiences of climate change events. Anyone who attends an event on climate change is either a high emitter or desperately aspiring to be there. When you think about what our system is in our society now, why do we go to universities? Why do we come to a place like this? We come here to get an education. That's all very nice. We come here to get an education to allow us to get a better job. Why do you want a better job? Because it gives us a better salary. Why do you want a better salary? Because you can buy a bigger house, a bigger car, fly further. Yeah, we want to consume as much as possible. That is the purpose that we have set up in our lives today to become high consumers. Our whole structure is set up like that. Our whole progress system is set up like that. Our whole status is set up like that. So we are asking some quite difficult questions about what it is we do and why we do it and how we do it. Equity, I would argue, completely reframes the climate change agenda. We haven't got to worry about 7 billion people. It's a myth to worry about the poor people in relation to climate change, and specifically here in relation to 2 degrees C climate change, so in terms of the carbon budget for 2 degrees centigrade. It does not matter about the poor having more children. That is a red herring usually spoken about by white men. Yeah, it does not matter, rich white men. Yeah, the poor will not become wealthy enough in the time we have to deal with climate change to be high emitters. We have now to 2030, really, to get our emissions down dramatically. In that time frame, the poor will not be wealthy enough. Just use, if any of you have heard of trickle-down economics, sort of Reaganite trickle-down economics, it has never occurred in the history of humankind. Even if it did occur, you could just test it out in the median income person in China or another part of the world. They never become wealthy enough in the time frame we have. Now, okay, if in the 3 or 4 degrees C world with a bigger carbon budget, the population matters. For sustainability, it matters, but not for 2 degrees C climate change. So there's a huge asymmetry in responsibility, but this gives us whole new opportunities because there are rapid near-term options for reducing emissions if you can somehow get that group on board, which is probably through regulation or examples then regulation. And also, I don't like this, but the world seems to believe in role models of one sort or another, which are not, I think, well, there's something worrying about that way of looking at the world, I think. But particularly celebrity-type role models. So perhaps if we could see the DiCaprios of this world, who I think is actually bought into climate change being a serious issue, but that's completely undermined as he gets in his private jet to fly to his private yacht to have a party with Madonna. It's just, there's something obscene about that. But if he was on a Greyhound bus, or if he wasn't to fly somewhere, he flew economy, he started to demonstrate that someone like him can live at least a reasonable carbon lifestyle. I think that could be really influential. You start to see a few people doing that. You start to see universities leading by example. Universities don't lead by example. Our carbon footprints will get higher and higher. Our progress means let's attract more foreign students. Let's have them flying out of the places. Every university around the world is doing the same thing, trying to attract more people, competing with each other. So, the academics are flying all over. You have to get a tick on your CV to have an internationalization agenda. The whole system is set up to maximize CO2 use. Now, we need to be demonstrating how to do that differently. If universities did that differently, then governments will start to take some notice of them. Virtually every child of a government minister goes to university because they never have normal jobs. So they all come to university. So, that we start to influence the system. We have that opportunity too. And remember, some of you here are young, it's your university. People like me are employed by you by coming here, effectively. So make people like me and make the senior people at our universities change the framing of our own universities to protect your future. This would all help catalyze system change. I'm not saying it's going to solve the problems, but you can actually start to catalyze a change in the system that then the governments can start to implement and scale up through policies and regulations. Climate change does demand system change. If you interpret Paris to the logic of carbon budgets, it begs fundamental questions of the norms and paradigms of the world in which we live. And certainly for quite a few of you who are younger, that's the only world you'll have ever known. People of my generation will remember some of the discussions that were there about communism and socialism and capitalism and all those other discussions that were ongoing. We lived through those different changes. We've seen how our society has evolved and changed a lot in the UK. Slightly less so in Sweden, I think. Try to resist some of those changes, I would suggest. If we are serious about climate change, we need a Marshall-style transformation of our supply technologies. That's like the Marshall Plan was the reconstruction of Europe after the Second World War when it was pretty much flattened. It's that level of change. We won't be making Volvos, we'll be making wind turbines and trams. You change the productive capacity of your society to resolve the problem that you're facing. So we'd be needing that. It's great for employment as well. Rapid penetration of energy efficiency technologies. a profound shift in behaviours and practices of people like me and most of us. And this sounds like an oxymoron, but to develop economic models that are fit for purpose, not the neoclassical marginal guff that we've been using for a long time to resolve what are system-level issues. And let's seriously start to think about intra and intergenerational equity. We just pay it lip service. We don't really seriously think about it. When you look at the way climate scientists behave, it's hard to believe they actually love their own children. You think about what we do. We have all the information at our fingertips, and our carbon footprints go up every single year. And we know, unless we're climate skeptics as climate scientists, then we know the impacts are going to play out on our children's lifetime. Not when we're there, possibly, or not so much when we're there, but the time we've gone. So it begs some quite difficult questions about how we live our lives. This has to start now and be completed in about 3 decades. This is quite a significant challenge. So I made a few points at the end. Hopefully, now that is a map of Gotland, I take it. So what would this mean for Gotland? What could it mean for Gotland? And I know I'm no expert in Gotland. Jesse and I arrived on the ferry last night, and that's about all we know, other than we spent a bit of time ploughing through the Gotland in Figures booklet, which I can highly recommend. It's a really exciting read. A rapid extension of wind farms. I think 40% of your electricity is from wind farms. Is that roughly right? Yeah, so 40%. Yeah, sometimes 45%. So look at trying to extend wind farms. Major solar program. And I was thinking about this. Now, I'm just saying these things. These may be really stupid ideas. But you have a massive increase of population during the summer. You are, at the latest year we could see, you're the 3rd sunniest part of Sweden. That's not, say that's not wonderful, but you're a pretty warm part compared to the rest of Sweden. Actually, a few years ago, for 3 years in a row, you were the sunniest part of Sweden. So you would have the solar power at the same time you had a massive increase in population, which means your energy demand will be much higher during that period. Could you look at hydrogen generation? So if you have extra surplus renewables, you use that when at night or during periods when you've got a lot more renewables online and you don't need the energy, you use that to produce hydrogen. Now, I'm not saying these things are easy, but you can do this. You then store the hydrogen and then you run it back to a gas turbine later on where you haven't got as much wind. So that allows you some seasonal variation in energy. So you start to think about these things. Now, they're costly, but they're not as costly as the impacts of climate change. So you can fuel gas turbines as backups. Sustainable pine oil and biogas from the forestry residues. The people here that know much more about forestry and certainly more about forestry on Gotland than I do, but that seems to be something we can start to think about. And there are one or two organisations looking at these types of things. If you look at the transport sector, a rapid shift to electric-only cars, or at least very, very low-carbon cars. And you're an island. I think you've got a whole suite of opportunities here that are available to islands that are not available often sort of mainland places. Could you go for no petrol or diesel cars on the ferries? So you got on the ferry and you'd have to have your luggage. So say you drove in your Volvo, which seems to be compulsory to own nowadays in Sweden, they're very heavy polluting cars. You'd get in your Volvo, you drive to the ferry terminal, you drop your car off, and there's some system whereby you put your luggage on a conveyor and it's taken straight onto the ship. You get on the ship, you get off at the other end, and you pick up an electric hire car if you want to have a car at all. And you pick up the luggage will come along straight in the back of your electric car, which is powered by the wind turbines and the hydrogen generator, and then you only use electric cars on the island. And you have to do it the other way around because there's poor people, they're not poor, but there's people living on Gotland who want to go to the mainland. When they get to the mainland, what they're going to do if they haven't got a car? So perhaps you could actually have a system whereby you get subsidised car rental ship over on the mainland. So you get off the ferry, you get in the car, and off you go into wherever you want to do in Sweden, but hopefully you'd use the trains instead. But you can start to think of system-based approaches to allow you to run quite a different thing in Gotland. And now you can all turn around and say, oh, that's impossible, this won't work, or that won't work. No one said this would be easy. It would be easier in 1990. In 2016, we have to think differently. Electric hookup for ships. I believe you're expanding your cruise terminals. So you're going to be allowed to bring 2 large cruise ships in, 340-metre cruise ships, I think it said. Now, these are highly polluting vehicles that will pump huge quantities of nasty particulates into the atmosphere, even if they're good engines. I used to work on these things when I left school for 5 years. So electrical hookup, it's called cold ironing in the marine industry. So electrical hookup for your cruise ships and your ferries. So when they arrive, they plug in. If they can't plug in, they don't arrive. So they don't use their generators when they're in port. Biogas for all rural as well as urban buses. Your urban buses are all biogas, so the Gotland in Figures told us, but your rural buses are not. So why not have those ones as biogas as well? A moratorium on airport expansion, a frequent flyer levy. You fly once, you pay the price for your flight. You fly twice, you pay twice as much for that flight. Third time, 4 times as much. Yeah, and you just an exponential rise in the price of your flights. And the levy from that can go on to subsidise the ferry and some of the cars you have to rent out as you get to the other end. On the ferry, okay, I mean, it just seemed a bit odd yesterday. Jesse, myself, and about 20 other folks seems to be coming over here on this ferry that probably could have held about, I don't know what it holds. I would have thought 1,500 people, something like that. I mean, you know, it's a big ferry. I was just thinking, I felt quite sad because I know that actually we would have been lower emissions for making the single flight. And I've heard that argued, but that is not an argument. It's an assertion. An argument means you step back from it and think of it from a system perspective. If you fly more often because it's quick, you can do it. If you go by ferry, you have to plan your life differently. If you fly, you say to the airports, expand, buy more planes that lock in high carbon. So the dynamic signal from flying means you have a much higher carbon footprint. It doesn't necessarily matter whether the ferry journey is any worse or better than the plane. It's the dynamic signal that really matters on these things. But you could have a ferry that was biofuel, hybrid, hydrogen. You can reduce the speed. It's a cube law for the speed. So reduce the speed, takes you a bit longer. But put some decent films on there. Get a cinema on there. Have a really nice restaurant car and subsidise it from the frequent flyer levy. So you think of it as a system you're trying to solve. You can make Gotland a place that could be a really good example. Zero carbon buildings. You've got a lot of old buildings here, and this is we were walking trying to find our apartment down this. What's the high street called again? Down that road. It's a very nice road, really attractive, particularly after coming from Uppsala, which is not the most attractive of high streets. But it's really beautiful walking down the lovely old buildings. But I was thinking at midnight when we were trying to find the right apartment, that these would be quite hard to retrofit because you don't want to destroy the beauty and the aesthetics of the buildings. But there are things you can do. You need to retrofit your old buildings. 1/3 of all your domestic properties, I understand, are built before 1930. It means they will not be very efficient. Probably the ones built after that, certainly until more recently, will not be very efficient either. So you need to retrofit those. There's a lot of work being done on that, a lot of technical work being done on external retrofit and internal retrofit to make those buildings very low energy use. You should be able to reduce the energy use by about 60 to 70% with good retrofit. Passive house standards on all new buildings. So do not build any buildings that are not passive house. In other words, no energy use. And also slightly surprised that I was just told before coming here that there's some house building going on the island, whilst you have other houses that are empty for most of the year because you have this sun spike in the summer. Well, you need to think about that from a sustainability perspective. Is it reasonable to build more houses with the other houses that actually have are only used for 5 weeks of the year? There's something inherently unsustainable about that system. So don't respond to it. Don't just carry on with it. Respond to it. Change it. Substitute cement and steel for wood. You could be going back to using wood. Sweden's very good at producing reasonably good quality wood, and I gather that some of the wood produced here is excellent. So, cement is high carbon and steel is high carbon. If you can swap out for wood, that locks away carbon as well. So there's lots of benefits to that. Other various ones, and this is going to be really difficult. Culturally, food is always a touchy one, but you eat a lot, or you grow a lot, don't you eat it or not? Most people in Gotland seem quite slim, so I don't think you can be eating that much of this stuff. But according to the numbers, there was a huge amount of beef and cattle and lamb was grown here. And it has a very high carbon footprint. It's the type of animals they are. The way they digest their food means that they will always have a high carbon footprint. And I think you have to think about moving away from those. And they will change some of the landscape. They will make it culturally a different place to be in some respects. They change the habits of how we eat and what we do. And but we have to respond to these things. Pigs and chickens are much lower, and obviously vegetarian lower again. There are plenty of things that we can do to live good quality of life without those. Hydrogen or carbon capture and storage on the cement industries. Don't close the cement industries down, because otherwise someone else is going to have to produce it. Well, often that's the case. You shouldn't always just think about closing things down. But how could you make them very low carbon? Carbon capture and storage is one thing to think about. But also, if you produce the hydrogen, you can use that in some ways to help with cement production and with steel production as well. Demonstrate decarbonised leadership in Sweden. I repeatedly make the point when I give talks on the mainland that Sweden is held up by lots of parts of the world as a leading example on lots of things. And my experience of coming here has been really positive. I think you've got a much more rich, flourishing, socially coherent society than many other parts that I've come across in Europe, certainly more than the UK. And I don't think the Swedes are that aware of it. You don't see it because you've been born into it. It's only outside you sort of see those things that are there. I think there's real scope for Sweden to show some leadership, but actually coming somewhere like Gotland, Islands are also places that can show leadership, and I think you might be able to show that within Sweden. So could you demonstrate what Sweden could be doing? Could you demonstrate what the climate law needs to have included within it? And I put up here finally, because it's something I did a lot of work on with a colleague quite a lot of years ago. And actually what we wanted to do was find an island where we could test it out. There's a lot of interesting work we did behind this, or I thought was interesting anyway, on personal carbon allowances. Because there's lots of equity benefits to that. You have a credit card that says how much carbon you've got. And every time you buy some fuel or you buy electricity or you buy a flight, it swipes off your card, your credit, your carbon allowance. And those people that consume a lot more quite quickly run out. And then they've got to go back in the market and buy it off other people, which means, of course, if you're selling it, you've got more money, which means you will buy some more things that emit carbon. And therefore, it forces, within a set carbon budget, the rich to make reductions in their carbon emissions, which a carbon tax doesn't. The other great benefit of it, because it does that, we know the early adopters of technologies are rich people, generally relatively wealthy people, often a bit geeky to start off with. And that actually we need those people to drive the innovation process. So the early adopters of new technologies are the people that drive the innovation process. And the personal carbon allowances drives that again, because these people cannot buy their way out of the problem. So there are lots of merits to approach like that, but it's actually really helpful if you could test it out in somewhere that had an island boundary. So something to think about as well. And on that rather slightly odd note to finish, perhaps, I'm going to finish off with this quote here that I always use from Robert Unger, that at every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. Now, I would argue the difference now is that it will be different. The world will be significantly different, either because we've chose to continue to fail on climate change, and that means then we will have to deal with the impacts of climate change, which will be disastrous regardless of where we live. 40 to 50% of the food in Sweden is imported. That will be affected. Much more migration, military tension, all those other things. So the world will change and be radically different, and not in a good way. Or we choose to make very difficult choices and challenges and face those challenges today in terms of reducing our emissions. And the job of us, I think, as academics and people in university, and that's not just means professors. As I remember, we've failed. We're relying on the younger generation to come up with new ideas because ours clearly didn't work. We need imagination to conceive what would a prosperous low-carbon future look like? Now, that's not just good enough to imagine that. You've then got to say to policymakers, how would you do it? What's the actual stuff you need? What are the changes in value system you need to engender through your policies and so forth, as well as the technologies? We have to provide the policymakers with that sort of level of understanding, and that is our job at university. So I think that in some respects we have a blank sheet of paper because we don't really know what to do. But that's quite an exciting prospect for those of us who sort of trying to think about the future in a different way. So on that upbeat note, after what is not necessarily always an upbeat talk, thank you very much for listening.
Thank you, Kevin.
Okay.
Now it's time for questions, and probably a lot of you want to ask some questions, ask Kevin. So you can just raise your hands. And
I particularly like disagreements. Yeah. Yeah. The problem is because they were not included directly in Paris, that makes it quite problematic. The aviation industry, and remember these are clever industries like most people in high-up businesses, what they know to do is to avoid regulation is you pretend you're doing something. Companies have been doing this for the last 100 years. And so the aviation industry got together in Montreal just a few weeks, well, maybe about 2 months ago now, and came up with a policy of what it's going to do. And it calls it zero carbon growth in aviation, but it means it's going to offset its emissions. So it's come up with policies to avoid it being included in things like the emissions trading scheme within Europe. And the IMO has said it's going to delay any action until 2023. And it was also written to the EU, said we think it's wrong to include our emissions in the emissions trading scheme. So the EU has, to its credit, tried to do something with aviation and shipping emissions, but both sectors have fought against that, and the other parts of the world have not supported the EU in doing that. Yeah. No. But also you've got to be careful. LPG is not low carbon. The reason they've gone to LPG is because of the sulfur controls. Now, there are strict controls on sulfur. The IMO, the International Maritime Organization, has put increasingly strict controls on sulfur because of the local health issues. That's one of the reasons you want to be very careful about letting them just moor up along the side for 6 to 12 hours, whatever they're going to plan them for. So the sulfur emissions from marine fuel is a real problem. It's recognised as a problem, and that's why some ships are talking about moving across to LPG. But that's not going to be low carbon, so it's still high carbon. But they can do that because it fits in their current model. It allows them still to travel as fast as they are. During the banking crisis, or just after the banking crisis, the shipping emissions went down. It went down partly because they were moving less stuff, but also significantly because they were reducing their speed, because their operating profits were lower. So they significantly reduced their speed, and because it's a cube law, they significantly reduced their operating costs with less fuel. So there are plenty of things you can do. And I've got other colleagues who are working on Flettner rotors, which are an old 1920s design of a technique for using wind to power the propeller, and other people working on kites to assist the propulsion of ships. Huge kite, not small children's kite. They're massive kites out the front, and you can provide quite a lot of power on those, and you sort of fly those in like a figure of 8 direction. So there's quite a lot of things, but all that requires like new training for the people on the ships. How do you handle that in ports and all those other things? And it still wouldn't resolve all of the energy requirements of ships.
I want to give you this.
I will try to talk as best as I can. A follow-up question for that one. I have, when we talk about ships, I heard that a lot. You can have these sails, you can have this parachute, but I never heard about electric motor for boats.
Yeah.
Why is that?
The storage capacity for the electricity at the moment. We're not very good at storing electricity. You have hybrid ones. Electric motors are used on boats. And in fact, one of the boats I sailed on back in the 1979 to 80 was actually an electric-powered ship, but the electricity was generated by a diesel generator. So there have been, and there still are, electric ships. The one, if you go on the train into continental Europe, the one you go on there is a hybrid, which presumably has an electric motor on that one. But it's still diesel. So it's a diesel hybrid. We cannot store those sorts of quantities of electricity reliably yet. It's okay for cars, but you still think about it. If I fill that with... What's one of the problems? Our society has been built with the idea that if that's full of petrol or diesel, you can go a long way on that. It's a wonderful, wonderful fuel, or kerosene. It's energy dense. You can transport it around. It's incredibly safe. If that was a battery, how far would you get? I'd probably get from here to the door if it was a battery. So it is quite difficult that we are trying to overcome a technology that has also completely embedded itself in our society, and a huge amount of intellectual effort has been put into improving it. So it's incredibly good how everything, whether it's a car, whether it's a plane, the way we're able to use this material now, petrol and diesel, it's really difficult to compete with renewables. It's difficult to compete with things like batteries and so forth. So we have to recognize there is a qualitative difference between the energy we can generate from renewables and batteries than that we can generate from fossil fuels. And that means we will have to make some changes to how we do things. So electrics for ship at the moment, we don't know how to store it. But I suppose if they were short enough, you could come up with all sorts of things about maybe you could have a cable you could attach to it, things like that perhaps.
Solar panel at the boat?
So we looked at solar panels. If you cover the whole ship and the most efficient solar panels known to humankind yet, you might power the generators, but you certainly won't be moving the propeller very fast. So, and it's the same with planes. I mean, you couldn't leave the runway with a solar-powered plane. You just can't get enough energy out of it, even if every surface was covered and the clouds were no clouds there. Solar has a lot to play, a lot of major role to play, but it's problematic on transport. You can't get the right energy density out of it. But you could use it to generate hydrogen. You could store the hydrogen and put that on a ship. There are issues with storing hydrogen, but we can improve and we can resolve those. And we've been doing it for years.
Thank you.
Okay.
I will try to do this because I don't have much of a voice right now, but I studied environmental science here, and I also studied in high school. And I just want to know, because you're an expert in this, so your message comes through also by being very rhetorical with us here. But for me and for my fellow students, I feel like it's hard to reach out to the denials, the skeptics, and the incrementalists. So do you have any, like, what's the key to reach out if you're a student, if you're not on the high top? How should we do to reach out?
Well, if you're a student, I said before that you're my employer. You can, as an individual or as a collective, you can put a lot more pressure on the places where you work at your universities. So you can ensure that those places are starting to move their practices, their technologies, their buying, their procurement policies, all of those things towards a future that is prosperous for you, which otherwise means they've got to make them much, much lower carbon and more broadly sustainable. And universities are not good at that. Most universities in Sweden have not divested. Most universities in the world have not divested from fossil fuels. So the research that's underpinned a lot of our concern about climate change has been undertaken in universities that at the same time are taking money from the fossil fuel companies and now they're also investing in the fossil fuel companies. That needs to be stopped. It needs to be stopped now. And then people of my age are not going to stop it. But we will stop it if you lot start to protest. When I was younger, students generally, people should moan about them, but they would get together and cause all sorts of havoc. They had a different voice. And that wasn't just in Europe, that was also in the States as well. And actually, historically, that's been the case. Students have often been the people that have demonstrated the early signs of uprising, whether that's in Vietnam or indeed some of the early stuff in the Arab Spring as well. And the students now seem much more content with their lot, or at least they're not voicing the same degree of concerns. At Manchester University, one of the biggest universities in Europe, we had a whole thing on divestment there, and about 5 people used to turn up from the student union. 5 people. Years ago, you'd have got 500 of them coming up, and they would have made a real noise, and they find out where you live, and there'd been placards outside your house as well. So I think you have a voice that you're not using collectively. And I know that other people here from the university may not like me saying this, but I do think we need to hear your voice. It is your future that we are screwing up, and you have some responsibility to make us change the way things are sorted out. You can also engage via social media, things like that. You can engage via the press. You don't have if you're at university, you're eloquent, you're reasonably astute, and you're well educated. You can start to write and engage, with policymakers, with business leaders, and so forth. Have the strength of your abilities to do that. You have all of that. If you can ask questions like you've asked me, you have all the wherewithal to make the sorts of changes that are necessary. And also, I can also do some help on Twitter trying to counter some of the skeptics. But don't get too involved with these things. And also be aware you'll have to have a tough skin, because you will get criticised. So you have to, and the nice thing about collectives is that if you are other people like yourself, that helps you deal with some of the problems that you'll face, because you will face sometimes quite nasty responses from people.
Thank you.
I'm just thinking if there would be a parallel to saving cost with saving carbon. In companies you need to save costs, and there's always a very easy way to save costs in companies. You can close them down and save all the costs. Now for flying so you always get something for the carbon dioxide that you are using. So I think world tourism is something counted to correspond to 10% of the world gross national product. So if you would close down all flying, if you go to zero carbon on flying, then you would miss that earning potential. So I'm trying to say that there could be problems. If we don't fly, there would be no animals left in Serengeti probably, because there would be no incoming money with people going there. So in some cases, when you do saving, like when saving costs in companies, if you save on the wrong costs, then you also lose the benefits coming out of it. So if you have any comment on that. Yeah.
Well, yes, but this is why I think we have to stand back and look at it. We have left it so late. It's a system change. For one thing, if you look at someone like Sweden, I can talk about the UK, and it's not that dissimilar to Sweden. Neither country, people don't flock here in their droves to enjoy our warm weather. So Sweden, I guess, is a bit like the UK. For every pound that flies into the UK as a tourist, this is a few years out of date now, but £2.73 was flying out. Now, I guess Sweden's the same. So if you can find sort of some method of staycation where people are encouraged to stay here, That's not just for longer vacations. Maybe they could use trains more often for those things within continental Europe, but actually for weekends and things. So rather than flying to Prague or to New York or wherever it might be that people might go for a long weekend, and rather than doing that, why not stay within Sweden? If you can find ways to do that, you maintain the tourist income within Sweden and have a lower carbon footprint. When it comes to things like the Serengeti and the animals and things like this, do we think that's important? Yeah, I think it is important. What we owe those parts of the world is reparation, not aid. Reparation is what we have destroyed their prospects to progress like we have because they can't use fossil fuels. We've also made it so they're going to suffer, and already are suffering, often some of the early signs and impacts of climate change. So it is our job, and actually Sweden's of course been much better on this in relation to the $100 billion that was laid out within Paris for the poor parts of the world. But it's the only country I think that's offered anything so far. That it is our job to offer the funds for those other parts of the world to protect things like the Serengeti, if that's how we have to deal with it. It shouldn't necessarily be just through our funds from being there as a tourist, if that means that's got a high carbon footprint. There are other ways to do that. And this is why I think we have to rethink the way that we're running our society. The animals in Serengeti aren't just there for the locals, they're there for diversity of the global community. And they have a not just an instrumental value, they have an existence value, a value in and of themselves. And I think we have to recognize those different forms of value and help poor parts of the world to protect them if they want to themselves. We have to be quite careful not to be too heavy-handed on some of these approaches as well. I'm not often that keen on the idea that we buy up other parts of the poor parts of the world to protect forests and things like that. I think there are some real issues on land rights and sort of colonialism that goes with that.
I'm going to take the opportunity to put a question myself before.
Okay.
And as we are here on Campus Gotland and part of Uppsala University, we should be quite embarrassed about this flying and carbon output to the atmosphere, because a lot of people fly back and forth between the mainland and Gotland. And I wonder if you have any good ideas and suggestions for how, apart from having video meetings and video conferences, but how can we solve this and stop flying and still have quality in what we are doing?
Well, it's interesting that, isn't it? Because, I mean, the final part of your comment then was actually stop flying and still have a quality that assumes that actually our quality of life is dependent upon the flying. And
no, as it is now. I mean, you have been touching upon this also about the other dynamic in, for example, slower travel with boat and better planning and so on. So
I mean, they're the things I think we have to think through. If we are going to travel, we have to. We want our cake and eat it is the expression we use in the UK. I don't know if you have the same expression over here. And that's not going to work. It's not going to happen. So we have to make some quite significant changes. The trick then is how do you make those changes that still give us a good quality of life? And some of those things are, like we have to travel more slowly. If you travel slowly and you don't do it as often, then your emissions will be much lower. But that often means then we have to restructure how we run our lives. It might be we have to restructure how our companies treat the employees, our attitude towards time off, or working whilst we travel, those sorts of things. So you might go away and you might spend longer, because it took you longer to get there. You want to go away less often, but you spend longer periods away when you do get there. So rather than you just go away for a weekend, you might go away for a week somewhere or a fortnight. And that's necessary because you've got to justify the 2 or 3 days the travel took you. So we have to find new ways to restructure these things. And that, like I often say on these things, it's actually to do with how we conceive the importance of time. So, there are technical things you can try and help with these. There are other things I was saying before. Make the journey part of the pleasure of what it is that you're doing. Now, I know people here, my guess is you just jump on the plane to fly to the mainland because it's convenient and you're not doing it for any other. It's not a wonderful thing to have to do, but it's convenient. That convenience comes at a cost, and that cost is borne by other people. So we were looking at the ferry numbers, and actually we were very surprised that even almost across the year, about only 20% of the journeys to and from Gotland are made by aircraft. Only 20%. So 80% are not. And that started to make you think, well, actually, if that's the case, we need to understand why is it that 80% aren't flying? And if we can understand why they're not doing it, maybe we can find better ways to mobilize the other 20%. And someone said already the cost was one thing that made a difference to them. Other people said they could take their car on it. So maybe if you had a frequent flyer levy, people would start to think more about the ferries. Are the ferries always reliable and nice things to be on? I mean, ours was fine, but they are right and fine. British ferries aren't always like that. So There's often things you can improve on them. But I was wondering if there are other things you can make special about the journey. Sometimes that's important.
But what can Uppsala University do? You say
Okay.
it's the structure of a company.
Yeah.
Well, it's a big old structure.
Yeah.
And, what will you and what can we tell the leaders to change?
Well, you could ask that departments must reduce their emissions in line with what the science university tells us about Paris. So fine, fly if you want, but 12% per annum cuts in emissions, which might mean you've got to reduce your lab costs or your or other things you do, the heating in university, to allow the odd person to occasionally fly. But you could say, why shouldn't the university do that? And then it has the choice. I mean, I'm not against flying. What I'm against is high carbon activities. Yeah. But if you let people have the choice, if people want to fly once a year and live in a cold place, then that's up to them. That gives us those choices. But I reckon as soon as you start to apply 12% per year, very rapidly the university will say you're not flying, you're going to go by ferry, because they can't, they could not make the cuts elsewhere. So use the maths and the tools and the science that we have and apply that within our departments.
Oh,
so
thanks.
You could do that, yeah.
That's a good idea. Sorry, you were first.
Thank you, Kevin. Great presentation.
Thank you.
And when we talk about climate change seriously, in conscious minds, it's very, very easy to conceive some kind of despair, frustration, especially if we sit in academic environment and you what I can do as a student, what she asked. And I think part of this frustration is because we actually do have already solutions, innovations, ideas, technologies, non-technologies, social innovations to solve all the problems and to shift the world right now. But due to political and corporative structures, we constantly hit the walls and we constantly basically hinder people, hinder resilient communities, hinder innovators to get there, to shift now, even we have all the knowledge. And in this context, my question is about decentralization. Like why, when we talk about climate change, new technologies, social structures, we so rarely mention anything about decentralization, not seeing this shift as a waiting for this top-down change which somebody brings to us, but as a cultivation of more resilient and grassroots initiatives in a way. So just to make it clear, I live in a quite curious place. We have our own wind turbine, we have our own solar panels, we develop our biogas production, we run only biogas and electrical cars, blah, blah, a lot of interesting things. And I would say that for the smaller unit, such shift takes so less energy and so less time and effort. So why, talking about climate change, we never, or very rarely, talk about change in the whole social structures?
Well, I hope I am trying to say here that we do need changes in our whole social structures. And I do think the bottom-up approach is really important, as I think is what you're sort of hinting at here, whether it should be top-down. Should we wait for the leaders, the entrepreneurs, whoever those people might be up there, to resolve this problem? And I think that's wrong to do that. Firstly, I don't think they know what to do directly, and most of us have got, as you say, most of us know what needs to be done, particularly those of us that work in the area. We know what the policies are or could look like. We know that sort of technologies need to look like. What we lack is the courage to put them in place. So we need more examples like the one you're talking about, because those examples are the ones that we follow up, that government ministers or universities might follow up. Very seldom do top-down people have the new ideas themselves. What they see are the ideas from elsewhere, and then they have to scale them up. So they might look at your community and say, well, how are you doing that? How's that working? And then they might think, well, what would you need to do to encourage other communities to do the same thing? What would the policy framework need to be? But without your community, you would never have those ideas. So I think that we have to recognize that this is a partnership between bottom-up and top-down. But the new ideas generally come from, we call it grassroots if you want to, individuals, whatever it might be. I use an example. I was talking about someone earlier. I use this example regularly, and Paul Jesse's heard me mention it many times. About there was a cashier, a person that works on the till in a big store in Ireland during the time of apartheid, when the apartheid was when we had the separation in South Africa from blacks and whites. And she refused to put through some fruit on her till So because it was a South African fruit. So they sacked her, the company sacked her, because she was a cashier. You can sack them and just employ another one. But she went outside and got some placards, some big posters, and talked about South Africa. And then her union joined her. In 6 months, that store no longer stocked any South African goods. Within 2 years, the Irish government had changed the law so you could no longer import any South African goods. And in 2008, the president of South Africa, Mbeki, went over there and I'd just say probably flew over there, but he went over to Ireland and he put a plaque outside the store to thank Mary Manning and the union for their support during the time of apartheid. Now, I think the world is full of examples like this, and we often just don't see them. And we shouldn't expect to be rewarded for doing the things. Like you do the work you're doing, and other people will see that. It will be having effects now that you're not aware of. And this is why I think this actually gives us some hope here, that the system is emergent, it's complex, and therefore we do not expect to see where all of the successful routes go. We need to do the best that we can where we can in our communities and our institutions, in our homes, in our sports clubs, and those things will percolate through if enough of us do them. And these are the examples that policymakers need to have. So I would say just carry on doing what you're doing. Talk about it. We have to talk about it. There's no point just doing it quietly. You've got to talk about it with others. So you've got to be vociferous. And if we are like that, I think there is real scope. If you put together 7 billion people's ideas, we can resolve these problems. At the moment, we're relying on a handful of people at the top who repeatedly let us down, and a corporate structure that is actually set up to completely undermine us as well. So I think we have to start to recognise that the power resides within us, which actually, the one area I agree with quite a lot on Naomi Klein, is that I think that we have much more power. We have not taken that power. So we know to recognize, there's large numbers of us, much larger than there are of the corporate elites. And we have to recognise that we have power if we choose to take the power. So that's why if you put, the question that came over here about students, the question you're putting there, all of these things are good signs that we want to act and we know what to do. We just need to go ahead and do it. Any other questions?
Yeah.
I
have a question regarding the Paris Agreement,
yeah.
Regarding numbers. And just to be not misunderstood, I clearly believe in climate change, and I believe that we have to change something. And yet I came across some articles which said that some numbers on which the Paris Agreement is based were not really super reliable, and this one person worked with this NOAA organization, Dr. Bates, came up and said, okay, these numbers are a little rigged. And I just wanted to know how big this flaw in the science was there. Because I think you're the only person right now who could answer that for me, because I didn't find too much in the internet about that.
Yeah, I would have to know exactly. I mean, we hear this all the time from the skeptics, always pointing things out that some of the numbers are rigged. And actually, it's just often the misuse of language, or the deliberate misuse sometimes by them. And sometimes, I'm not saying by you, but them, but also sometimes a misunderstanding of what science is. Science has never given black and white answers. It never gives right answers. And what the point about science is that it's best interpretations of what we have available. Now, it may well be that some people have, and I remember the discussion on some of the NOAA stuff, there's been a lot of responses to that, to say that actually, that it's been completely misread by the climate skeptics. And I would argue deliberately so. So my understanding was that you could have had better protocols for storing the data. But the person that complained about it happened to be someone. I mean, there's a whole lot, without getting into it, the person who made the complaint was a data analyst who had been effectively fired from his job. And he then said that these scientists haven't been using the right protocols for doing what they should have been doing. And I think from what I could tell, he's broadly right. They hadn't been using the right protocols. In other words, they hadn't been storing the data in the way that they should have been storing the data. The data wasn't wrong. They weren't doing it incorrectly. They were just probably trying to rush it a bit too much and do things in a way that didn't tick all the right boxes. And it's important these things are pointed out. The problem then is people say that means there's something wrong with the science. My understanding was there's nothing wrong with the science. There's been lots of scientists that have come back to show that the data they were talking about has been replicated in many other studies that are independent of theirs. But let's be clear, science does not give right and wrong answers. It's the best interpretation and understanding we have at the time. It always has quite large ranges of uncertainty. But overall, we use the science we have to give us a clear picture. And I think climate science is probably one of the most robust sciences. Well, it's just normal science, it's physics, but robust areas of endeavour that we have understood, because it's been tested over and over and over again, because so many people have been sceptical about it. So I actually have become much more accepting of the science simply because the skeptics have pushed it really hard. And I think the skeptics, they wouldn't want this accolade, but I think they've actually done us a service to some extent. And they've made the climate science community be really clear and be really open. But I think at the end of the day, they've shown that their analysis is correct, and the climate skeptics' view has proved to be wrong repeatedly. But it is important that we try to be as open and honest as we can be, and when we make mistakes, we have to be honest about those mistakes and rectify them.
I think we have to finish there and thank Kevin again for a really engaging and disturbing.
Oh, upbeat, I hope.
Yeah.
A bit upbeat.
Yeah. And we must think of what climate tribe we belong to and so on.
Okay.
And a big hand for Kevin, I think.
Thank you very much. Thank you.
And a small gift, something from Gotland.
Oh, lovely.
Thank you.
Thank you very much. That's much appreciated.